Let's talk about why critical electrical systems fail. And hey, it's not for the reason you'd think. That number, it's the cost of lost production from just one totally preventable failure. So the problem isn't the hardware itself. Nope, it's in the paperwork during the selection process. The tech itself is actually super reliable. The real challenge, matching it to the real world. So our first cautionary tale, a system designed only for today's needs, not tomorrow's. Fast forward 5 years, a utility upgrade changes everything, pushing that system way past its limits. And just like that, the breaker is undersized. It's a dangerous condition you'd never see on a schematic. The key to preventing this? Build in at least a 20% safety margin for the future. Okay, next up, a mining operation. Here, the biggest risk isn't a rock slide, it's the air. See, the problem is that air acts as an insulator. But at high altitude, there's just less of it. That lower air density weakens the invisible electrical shield, which really bumps up the risk of failure. And the international standards are totally clear on this. Above 1,000 meters, standard gear just isn't standard anymore. You know, just one line in the spec sheet can prevent this whole category of failure. Seriously. And for our last story, we've got a switchgear room that was definitely not what it seemed. This really shows you the huge gap between a building's label and its actual pretty harsh environment. So what happens? The equipment is slowly destroyed by conditions it was never built to handle. Period. The lesson here, you have to spec for reality, not just the name on the door. So how do you get it right every single time? Let's look at the solution. It comes down to a simple checklist. This turns all those warnings into a blueprint for success. And here's the bottom line. Doing your homework up front can save you millions down the road. Which leads to the final question. When critical systems are on the line, what's the real cost of good enough?